Hello from DBK Consult. Our concept is picking any piece of architectural drawing, and together we can walk through all the stages involved in how you can produce a complete and detailed structural drawing that can be applied on site. Today we'll be having a little marathon, and we'll be looking at how we can complete a full structural design. This video will give a detailed approach to the steps you can follow when you receive an architectural plan, up to how you can come up with your suitable design structural members. The principles in this video is not just limited to a ground plus two suspended floors, but it can also be applied to other structures. And if you find this video helpful at any point, do not forget to like it, subscribe, and also turn on the notification bell so you get notified anytime we post new series. Now, this is the architectural piece that has been provided for the complete analysis and design. Like we said earlier, this is a two-story residential structure having our ground floor, the first and the second floor, which is a ground floor plus two suspended floors. So we have over here the corresponding elevations and the sections. We'll start off by creating a copy of this drawing. So we can start with our general arrangement. So we have to create a copy, so we did not tamper with the existing dimension or the original drawing. We can make modifications to this copy drawing. The general arrangement phase for you as a structural engineer is more or less the most important phase, because this is where you get to predetermine the positions of your proposed structural members. And in this phase, you also get to marry your proposed structural members with the architectural plan. So if there should be any discrepancies with the proposed structural plan and the provided architectural plan, we can as well sort them out easily. So we'll start off the general arrangement by studying the architectural drawing. And we'll study this architectural drawing with respect to the elevations and the grid lines. So if we come to the elevations, you will observe that at this very elevation, which is the approach view, this is our ground floor, this is the first floor, and this is the second floor. So you will observe that we have an increment in size here. So this in turn tells us we have a cantilever on this structure. So there's an increment in size at the left hand side and also at the right hand side. So let's come to other elevations as well. You can see that we also have a cantilevered part here and also a cantilevered part here. So this should already be telling us that the proposed structural plan we have for our ground floor might not be the same structural plan we'll use for our first floor, making due regard to this increment in size when we are moving from the ground floor to the first floor or other suspended floors. So this is the changes we can see externally from the elevations. Then let's go to the plan view. Then we observe our grid lines. So to see this drawing very clearly, I will appreciate we take out these dimensions, so we have just the block walls and their annotations. So I will first select one of these dimensions. Then I will observe the layer. This is under dimension layer, and I will select these three drawings, right click, then I will use my quick select tool to select those dimensions. I'll come to layer and I will look for dimension. Then I'll come to the object type and I will select rotated dimensions. Okay, so as you can see, our dimensions has been highlighted. Then we can go ahead and erase these dimensions. So now we have a clear view of the internal walls on this very structure. So over here we have the start of this part on grid line A, and we have it ending on grid line H. Okay, so if we come to the first floor plan, as you can see, we have this on grid line A, but we have this other wall coming out of the boundary of the grid line A. So this in turn tells us that this cantilever we have on the left hand side on this elevation does not affect everything here, it only affects from the position of this grid line B. Okay, and if we come back to our ground floor plan, there is an indication that we have a cantilever when we move from this ground floor to the next suspended floor. Okay, so this broken line over here denotes we have a cantilever. As a result of this cantilever, there are chances our proposed schematic for the ground floor will not be the same structural schematics that will be applied to the other suspended floors. So we'll start off by creating our proposed column positions on this very structure. And let's keep in mind that whatever column positions we are proposing here is actually tentative and is subject to change at the analysis and the design phase. So we'll create a layer for our column. We'll come here to, let's close this. Then we'll come here to layer properties manager, and we'll click here to create a new layer, and we'll call this layer columns. Let's change the color to a blue color. Then let's increase the thickness to, let's increase this to 40 millimeters, and we'll set it as the current layer. Then let's close this up. So looking at the width of our wall, if we dimension this wall, you will see that we have a 225 wall here, and this other part we also have a 225 wall, which equates to our 9 inches. So we'll create a column having the same wall thickness as this, having the same dimensions as this wall thickness, and we'll come here to create a rectangle. Then we'll type 225 comma and 225. Okay, so now we have our proposed column. Let's go ahead and hatch this column. And we'll also put this at a blue color. All right, so we'll be picking positions on this ground floor plan. As construction demands, we have to start from the ground floor. So we'll pick adequate positions on this ground floor plan to receive our proposed column. Then after that, we'll take this proposed column to the first floor, and we'll see how this column interacts with the changes that has been made on this very first floor. Okay, so let's come here and copy this. We'll copy selection, and we'll copy from this center point. So we'll be working grid by grid, and we'll try our possible best to ensure our columns are always between walls. So during construction, they can be covered by our walls. Okay, so we'll pick the first position of our column, and we'll put this at this edge. Then we'll also work with this grid line B. If the proposed positions of our column does not have any grid line, then we can go ahead to create our own grid lines. But it is always advisable we start with the grid lines that comes with the architectural plan. So while constructing the architectural plan, the grid lines on your architectural plan will be same as your grid line on your structural plans, but we can also add our own grid lines in order to suit the requirements of the structure. So we'll come to this part, and we pick this next position within this helpers room as our next column positions. So while we are doing this, we will try to ensure the spaces between our columns are not much. So let's check this. This is about 3.85 meters. Let's see if we can take this next column to here. Okay, this is about 8 meters, and it is not advisable considering considering the size of the columns we are using. So we'll leave this column here, then we'll move to the next grid line. So we can also run another column in between these walls. So we'll pick this next position, and the boundaries of our staircase, we will have columns there. Then also at the boundary of this other staircase, we'll have another set of columns here. Okay, then we'll move to the right hand side. This should be the next proposed column position. This as well, and let's try to check the distances between our columns. This is also 3.825. This should be the next tentative position, and let's check this distance. This is about 4.275, which is actually okay, and the last distance is also 3.825. So let's copy this. So here, okay, and the next is also at this position. Then on this line, we can move on to the next grid on the horizontal axis. So we'll move to this part, and we can put a column here. So we can put a column here, and this column will also help to support this cantilever that is coming at the first floor. So this is a good position for our column. You can also copy this from here, and this should be another proposed column area. This will also be another proposed column positions. Then between these premises as well, we have another column here. Then we also have this that will help to support this cantilever, and we move on to the next grid line. So we can pick a column here, but let's study what is really going on here on the 3D plan, okay, on the 3D picture. So if you open up this 3D picture, the rendered view, you will see that we have provision for column here. Then what is next to our column is the flower vase, okay, and we also have another proposed column here. Then this other part, there are options for columns inside any of these other added members. So let's come back to here. Then we can copy this and use this as our another proposed column positions on this grid line. Then you don't necessarily need to use the dimension size that was provided by the architect. So a column size of 600 by 225 was provided, but you don't necessarily need to use that very size, because this is just a simple residential structure. If we design and this 225 by 225 column does not pass, there are options for us to increase at the analysis and the design phase. So they can construct these other parts of the column. If they really need to attain what was proposed by the architect, they can construct these remaining parts over here with our blocks, okay. So we'll come back here, we'll select our column from the center point. Then we have another column here, okay. We can also have another column here. Then we already have for our staircase area, and we'll put another one here, okay. We'll also put another one in between these walls. Then we can put the last one at this corner. Alright. So now we are done with the proposed position of our columns on the ground floor. The next step is copying these proposed columns onto the first floor. Then we get to observe the interaction between this proposed column and what has been altered on the first floor. So we'll come here and we'll select all of this and we use our quick select tool. We'll right click, come to quick select, come to layer, then we change this to columns. I will click OK. So as you can see, we have our columns highlighted. So now we can copy these columns using the copy command from the intersection between grid line A and grid line 3. So we'll copy this. Then we'll come here and paste also at the intersection between grid line A and grid line 3. So we can put this here. Alright. So now we have our columns copied to our first floor. Then we start by observing this interaction between the proposed column and this first floor. So starting our observations from this first grid line, from the grid line A, the column we have over here can still be used on the first floor because it's also serving at the corner and it can also be hidden in between walls. Then we move on to the next grid line, which is the grid line B. We also have same case here. Our columns can also be used on the first floor. Now moving on to grid line C, you will observe that we have an interaction between this column on grid line C and our door over here. Okay, so this will, if we continue this from the ground floor up to the first floor, this will interact with this passage, the passage door here to the terrace. So we'll make modification to this in order to suit this current arrangement that is occurring on the first floor. And this is as a result of this cantilever. Okay, let's erase this as well. So this is as a result of this additional cantilevered part. Okay, so let's take note of this column here and let's create a new layer for that. We'll come to layer properties manager and we'll create a new layer and we'll call this discontinuous discon columns. We'll set the color of this to red and okay. So let's also set that layer as the current layer. And we'll put a circle around this column to indicate we'll be making modification to this. Okay. Then the next is this column as well. As you can observe, it is no longer in between walls. It's actually at the center of this entrance to the staircase area. So we'll also put a circle around this so we can come back and make modifications to all these columns. The next is this as well. We'll also take note of this. Then the next column on grid line F, we'll also take note of this. The next column on this grid line, this is actually not affecting anything here. Our window ends at the beginning of our columns. Okay, so this is actually good to go. We can take this from the ground floor up to the first floor. Same as this on this grid line. Then we'll move on to grid line 2. This is actually still between walls, so we can still continue this column. This is actually between walls as well. This is between walls as well. So I think all the columns on this very grid line are still hidden between walls and they do not disrupt any of these doors or any of the windows. Then we move over to the third grid. So let me erase this. We move over to the third grid. And on this third grid, if you observe, we have our column coming out directly to the bedroom area. Okay, so if we have to maintain this column from the ground floor up to the first floor, we will have this column coming out at this bedroom, which is not actually good. Okay, so we'll take note of this column as well. Then this is okay, is in between walls. We can work with this. This is also in between walls. We can also work with this. This is in between walls as well. This and this is coming out at the bedroom area. Okay, so we have about 6 columns to deal with, and we'll work together to see how we can resolve issues like this when you encounter them during your analysis and your design. Now, to solve this problem, it's very simple. What we need to do is introduce beams in order to redistribute these columns to other areas that will not affect the aesthetics of this structure. Okay, so we have to do that by introducing beams, and that will lead us to our beam general arrangement. So we have to marry both the beam arrangement and the column arrangement. So what we need to do is we'll carefully observe these positions, and let's start with dividing our screen. Come to view, come to viewport configuration, then come to 2 vertical. So we have same drawing, but we can work on 2 of these plans, the ground floor and the first floor, simultaneously. So we'll put the ground floor plan here, and we'll come here to put our first floor plan. Now we'll be running our beam structural arrangement on the existing column, starting from the ground floor. So we'll try our possible best to ensure our beams run on the wall lines, unless except where necessary. And this is to allow us cover these beams by the walls that will be constructed on site. So we'll start off moving from grid to grid. So we can run a beam from this column to this column. We can run a beam here. Then moving between grid line B and grid line C, you will observe that from the ground floor, we have a provision for cantilever here. We can either support this by a cantilevered beam, or we can introduce a column somewhere here that will also help to hold this cantilever that is coming here. When we get to this part on the first floor, this column that will be introduced here will also provide support for this beam that will come to this other grid line, that will come to this other part. Should in case we intend to treat here as a panel, and we intend to treat this other part as a panel. Okay, so I will prefer we'll start off a column from the ground floor. Remember, whatever we've done here is actually tentative and is subject to change. Okay, as you are making modification on the first floor, this is subject to change. And let me create a grid line between these 2 points. Okay, I'll drag this up, then I'll match the properties of this to this. Let's erase this and this as well. Okay, so now we can copy our column from this part to this part. So we can run a beam directly from this part on this wall that will be constructed here. We can run a beam from this grid line A up to our grid line C. Then from here, we can send a cantilever out in order to carry this part that is coming here. By the indication we have over here, it means we cannot put columns at this very position. Okay, this is just a handrail. So this will only receive something like a slab. This will receive something like a slab, and handrail will be constructed from here to this part. So this tells us that there is no consideration for inserting column at this edge. So what will carry this part of the slab will be this little cantilevered beam that we'll introduce here, or we can decide to design this part as a fully cantilevered slab. Okay, so whichever works. We can have two structural engineers can have different structural arrangements, but these are the basics that guides you to creating a general arrangement. So what we'll do is we'll take out this entire part here, then we'll treat this as one panel, and we'll treat this other part as another panel. Okay, so we'll run this beam from here to here, and let's match the properties of our beam with this newly introduced cantilevered part. We'll match this to this as well. We'll match to here and to this part. Okay, we can extend this to this part. Okay, and trim out here. So why this is advisable is when you get to your Prota structure is you will just get to trace these lines in order to achieve your beam lines. You only have to trace these lines. You don't necessarily have to always go back to your AutoCAD drawing and look at the modifications. You can just draw your beams on this line that you've created from the general arrangement phase. Rename this and name this new introduced grid line. So we'll call this B asterisk. Okay, and let's move on to the next grid line, which is our grid line C. So if you observe the grid line C on the ground floor, we'll also look at what is happening on the first floor. So the grid line C is where we have the column interacting with our proposed column interacting with the door position. So what we can do on this first floor is we have to move this column to this point, but before we can move this column, we have to support it with a cantilever. Okay, so we'll cantilever this beam. When this beam is running from, let's take this out. When this beam is running from this grid line up to this point, it will have to cantilever till this edge. Okay, it will cantilever to this edge. So it is at this edge that this beam will be able to receive this column at the first floor. Okay, so we'll create a grid line here. We'll create a grid line in between this point. We'll create a grid line here, which is the same distance as here to this point. So let's check from the grid to grid. We have a distance of about 450 millimeter. Okay, so we'll also offset this grid line on this other part. We'll offset 450 millimeter. So this now becomes your grid line 3 asterisk. Okay, then we can match these properties with this. So on this first floor, what we'll do is we'll create this copy and we'll put it at this center. Okay, then let's take out this hatch and we'll match, let's take out the hatch on this other column. Then we can match this our discontinuous with this. So this is to tell us that when we get to this first floor, this column here will turn to a discontinuous column, which is in red. Then the column that we start at this very part is this blue column, which will be resting on this cantilever that we've taken from this other grid line 2 up to this point. Okay, so we've solved this very issue. Then we'll move on to the next. And by my observation, this beam should be running straight across from this point up to this last grid. Okay, because we have a wall running all through this part. So what we'll do is we'll just extend this beam from here to this position. So we'll have a straight beam. Okay, so we'll move from grid line C and we'll go to grid line D. So we'll also observe what is going on. Okay, I think we actually worked on grid line D. So it's still the same concept. We'll have to take this from here to this part, and let's erase this. This will be our discontinuous column, and this will be our newly introduced column at the first floor. So we'll also push out a cantilever from this point up to this point. Okay, so now we have our cantilevered beams that should be catering for the newly introduced columns. We'll continue with, in this regard, we'll come to grid line F, and we can as well grid line E we'll start with grid line E. Then let's extend this to here. We'll also extend this as well to this part. Then we can come here to select this and also select this. Then we'll copy from this center point to this center. We'll take out this and take out this. Then we'll match these properties with this as discontinuous and also match with this. So any of these columns that we've settled, let's take out the circles around them. So let's move from grid line F and come to the next part. So after grid line F, as you can see, we have this same cantilevered handrail here. Create a grid line between these 2 points. Okay, create this and we'll extend to this part. We'll match the properties. All right, so we now have our grid lines. So we can introduce a new column here, copy from here to this. Okay, then we can treat this part as one panel, and we'll also treat this part as another panel. And let's extend this to this, and we'll trim this other parts out. Okay, all right, so now we've concluded on the paneling of this top part. And one thing is, after we cantilever this on the ground floor, we can as well choose to cover this part up with a beam. Okay, we can choose to cover this part up or close this part out with a beam. So if we offset 225, we can choose to make this part covered with a beam, but it's really not necessary, because this span from this place to this place is just 450, and if we take out 225, we should be having just about another 225 for our slab. So it's really not necessary, but some persons can decide to cover all the edges of their cantilever with a beam, so they have something that looks just like this. Okay, we can now have something that looks just like this. But if you do not cover it with a beam, we can just have the slab that cantilevers outside. So now we are done with the first set of panels, and let's move on to this down part, okay, which is between grid line 2 and grid line 1. So we also start off from our grid line A, and looking at this column on the grid line A, you will observe that we have an issue to treat here, which is the column that is coming out of the bedroom area. So what we can do to treat this issue is, so we'll run this beam from this part up to this point. Then we can extend this beam as well to meet this cantilever. Then we can now distribute this column to this point, or we can even distribute to this other point. But we will have to run the beam from here up to this part. Okay? So what we'll do is we'll select this and we'll extend this our beam line. So it will run from here to here. Let's take out this aesthetics. Okay, so we have this, which is same as this, and we also run another beam from this column to this column. Okay, so a beam should be running from this part up to this part. So let's just extend the beam. Let's extend this. Okay, I will extend this as well. I will extend this as well. So we'll have this other part of the beam to cantilever to this additional part. Let's match the properties so we have the same properties. So we'll extend this to this part. Then we'll also extend this to this part. So this cantilever is what will carry this column here and also carry this column at this end. That's if we decide to distribute this column both to the left and also to the right. We can as well just distribute this column to this part on the first floor. So when we get to the first floor, we'll cantilever from here, cantilever from this part, and close it down with this other beam. Okay, so we'll create a grid line in between this extended wall, and the distance should be 600. So let's extend this newly created grid line from here to this part, and we'll also get to offset this at 600 from this part to this part, and we can call this 1 asterisk. Okay, so we have our support both here and here. Then what we'll do is we'll also create another grid line between these 2 points, and let's take this up. We'll match the properties. We'll copy this and let this be a asterisk. All right, and this is also at a distance of 600 millimeters. So we'll offset this here 600, and we'll get to rename this as well. Okay, all right, so we'll copy this column from here to here. We'll also copy this column from here to here. Then we'll erase this hatch and match this as this. So this becomes what? The discontinuous column. All right, so let's also extend this to indicate there is a beam running here. Let's extend to here. This this and we match these properties. Okay, then we'll move over to the next grid line. We'll move over to this next grid line, which is our grid line B. So if we observe our grid line B, our column is still in between walls. Okay, so we don't necessarily need to move this from this point up to this point. And due to the fact that we have a flush here, okay, this part did not increase with the cantilever. Okay, it flushes at the same window point, so there's actually no need to move this from here to here. Let's leave it at this corner. Okay, so it can create a very rigid base here. Okay, it can create a very rigid anchorage. So it will start from the ground floor, go to the first, and if it also flushes on the, okay, if it also flushes on the second floor, which it is, then we can leave this column to move from the ground floor level up to the first floor and up to the second floor. So what we need to do is we just have to cantilever this part out, and we'll also join it with this other beam that is coming from this part. So we'll extend this to this. Okay, and our next point of contact should be grid line B asterisk. Okay, so let's recreate this grid line on this first floor layout. Let's create this. Yeah, we'll drag this up, we'll match this with this. Okay, so this should be our next point of contact, and due to the cantilever at this part as well, we'll create a copy of this column to this part, so it will support this cantilever coming here. Then we have a decision to make. Okay, we have two options here. It's either we get to run a beam on this very part. Yes, because if you observe, we have a larger sitting room here. Okay, so it's either we get to run a beam at this very point, or we can decide to stick with the same beam arrangement that came with that comes from grid line C. Now if we choose to use the same grid line that comes from grid line C, it doesn't really affect anything here, because this beam will be under this sitting room area. Okay, the beam will run on grid line C will be under this sitting room area, while this other part is a car park. So if we get to have a drop beam at this car park area, I don't think it really affects the aesthetics of this structure. But when we get to if we get to the second floor and we have this same sitting room area, let's check that out. When we get here and we have this same sitting room area, we can no longer run a beam from grid line C. We can no longer run this beam from grid line C, because if we run this beam on grid line C, they will get to see it when they are sitting at this sitting room on the first floor. Okay, so for this very first set of beams, we can as well ignore and play with it, because this part is a car park. But on getting to the first floor, when we are making arrangements to receive the slab that will carry on getting to the first floor, while we are making arrangements to receive the slab that will carry the second floor, we must have to, or we possibly have to, run a beam on this very grid, which is our B asterisk. We have to run that beam here, so as not to have this beam running on this other grid. So this can now serve as what? This can now serve from this point to this point as one panel. So with that understanding, let's extend this cantilever to this place, and we also extend this part to here. Okay, so we have this as a panel, we have this as another panel, we have this as another panel. So we'll also get to run the cantilever here to here. Then also we'll get to run from here to here. Okay, so we are done with our grid line C, and on this grid line C we'll be moving this from this grid line onto this grid line. Okay, that's when we'll get to the first floor. So I will match this to be a discontinuous column, and we'll come back to this part. Okay, so we'll stay with these other arrangements. Let's extend this to this part. So we'll stay with this arrangement. We move to the staircase area. We'll get to retreat this part. When we are superimposing this very layout on our second floor layout. So we'll get to treat this part and see how we can solve this sitting room area. Okay, so we'll move to the staircase area, which is this, and we'll match our properties to indicate our beams. We'll match this with this. Then let's also cover this part up with a beam. Okay, so let's offset 225, and we can cover this part over here. Okay, so also offset 225 from this point inwards. Then we'll do the same for here and the same for here. Let's match this. All right, so we'll move from our grid line D, which is at the staircase area, to this other grid line. So it is clear that this part we have a straight beam coming from this place to this other part. So let's just extend this to here. Then the next is our grid line F. Okay, so we'll take out all these parts, and we'll extend this to this part, and we also extend to this part. Okay, so we'll have here as a panel, and this part will be a cantilever. Okay, so let's also take note that this beam, this column will also move from here to here, and will also be a discontinuous column. Okay, so we'll move to this part as well, and we reintroduce a new column for this cantilever. We'll copy this. This is just a replicate of what we've done on this left hand side, and we'll erase all of this. Then we have our cantilever just coming out from this part. Okay, then to solve this final issue here, we'll do the same thing we did on the left hand side, and we'll extend this here, extend this as well. Then we can choose to copy this from here to here, and also let's create a grid line, and also copy this from here to this part. Okay, so we'll match the properties. We'll copy from here to here. We'll erase this. We'll match this as what? Our discontinuous column. Okay, so these are now the columns that we get to hold this first floor. So do not forget that everything we are doing here is tentative, but at least 90%. So during analysis and design, there are chances we might get to make further modifications to this general arrangement. But for now, we have a clear understanding of what we want to model when we get to Prota structure. So let's also create this grid line here, which is at a distance of 600. Okay, so we'll offset 600 from here to here, and we'll call this, we'll come here and call this H asterisk, and there should be a grid line here, and this should be F asterisk. Okay, we have to ensure that all the columns on this ground floor are captured on the first floor. So let's see, we have column here on grid line A, B asterisk. We also have on grid line A, B, and B asterisk. So we'll copy this from here to here. All right. Then we have on C, which is this discontinuous column. We have on E as well, the discontinuous we have here, and we also have on F asterisk. Okay. So let's create this grid. Then we'll drag this up and match the properties. We'll copy this to here. We'll copy here. And we'll edit this to F asterisk. All right. So we have a column running from here to this part. Okay, so we have this column captured. We have this captured as well. We have this captured. We also have this. We also have this and this, which is the discontinuous, and we introduce this here. Okay. Then we have this. We have these two. Okay. We have this one here. We have this other one here, which is the discontinuous, and we have these two at the cantilevered part, which is here. Then we have this discontinuous, which is this, and finally we have this, which is what? This. All right. So the next step is just copying this column onto our second floor plan. So let's select everything here. We'll right click, come to quick select, come to layer, columns. We'll copy from here to the interaction between this grid line A and 3. Then we'll also come to paste between grid line A and what? 3. All right, so let's see what is also happening on the second floor. And on this second floor, we'll be making a little modification to our first floor plan, because our first floor plan is what we will observe to make modifications to the second floor plan. So like we said earlier, in order not to be seeing a beam here, because we cannot continue the same beam arrangement on grid line C. Okay, we can't continue this same arrangement on grid line C, because if we are to push that same grid at this sitting room area, okay, so if someone is sitting at this sitting room of the first floor, the beams that are supporting this grid on the second floor, okay, it will have to drop. So whosoever is sitting here will get to see that drop beam straight into the sitting room. So this is not a very good practice. So we can as well make further modifications to this first floor plan in order to carry whatever is coming from the second floor. Okay. So what we'll do in this case is, against having that beam running on grid line C, we'll come here to this part and we'll run our beam on grid line B asterisk. So we'll copy this from here to here. We'll edit this to be asterisk. So we can choose to delete this part, and this beam will be constructed on the block wall, so it will be hidden. So we can choose to extend this here and come here to, let's say we introduce a new column here. So we can treat this as one panel, and we'll treat this other part as another panel. Okay, so we create a grid line at the midpoint between these two. Put on the auto. We'll extend this out. We'll match the properties. Okay, so we'll have a panel here, and we can choose to treat this other part as another panel. Okay, why we choose to treat this other part as another panel. So let's check this dimension. We have here as 3.675, and we have here as 6.450. Okay, so this is the full width of this slab. But for the beams on this part, this beam has already been broken, so we should be having beams running at the interval of 2.85 meters and about 3 point something meters, which is not bad. So we'll also get to break this beam. Okay, we'll get to introduce a beam here. We'll also get to break this beam. So we'll copy this from here to this part, so we can break this beam. This will act as a support. It will cantilever and rest on this, then it will also cantilever and rest on this other beam that is coming from the staircase area. And you don't have to worry about this very column coming directly on the slab below it, because we previously have a beam running directly on grid line C at the ground floor. So the column will just have to rest somewhere around this part. Okay, so the column will be introduced somewhere around this part, which is actually on a column, on a beam rather, and not directly on the slab. Okay, so the modification we've made on the left hand side, which is here, we'll also get to make it on the right hand side. So we'll create an additional column here, and we'll also get to create a column at this part. So do not forget, we had a beam earlier running on the ground floor, so this column is safe. It will not get to punch our slab. It can rest directly on that beam. So with this, we can choose to run a beam at this part, and this will be a panel. Then with this arrangement, okay, we can also choose to treat this part as a panel and also treat this part as what? A panel. Okay, so we are actually done with our general arrangements, and now we understand what we should be modeling when we get to Prota structure, and this makes our job a lot easier. Okay, so let's export this as a DXF, and we begin the modeling phase. If you find this video helpful at any point, do not forget to like it, subscribe, turn on the notification bell so you get notified anytime we post new videos on our channel. Now, to export to Prota structure, what we need to do is save this drawing in a DXF format. Okay, select everything, type W on your keypad, which is block, and click here. Then come to this part and change this to DXF. So we'll be going with DXF 2018 format, and we can save it as any name. Let's say this as complete pad design. Okay, then you can choose your preferred location to save this file, and we'll save this. So let's minimize and go to our Prota structure. So if we open up Prota structure, we'll come here and create a new drawing, and we'll call this complete underscore pad complete design underscore with pad base. Okay, so we'll save this, and we'll be designing with the BS8110 and its corresponding code. So we select this and click import. And here we have the blank drawing. Okay, so this is our structure 3. These are our design components. So let's import the drawing that we just exported out of AutoCAD. To do that, we can come to File, come to model/file import, then we'll model/file import, then we'll come to external reference drawing, or you can just click on this icon here, which is also the external reference drawing. So we'll click here, and we'll come to load. Then you come to the folder where you saved the AutoCAD file earlier, and we'll click on this complete part design. We'll click OK. We'll leave this in millimeters. Then come over here to import your members. Okay, so we'll click here, and to import our axis that we've been using on our AutoCAD, we'll click on import axis, and those axes were actually on the grids layer. Okay, so we'll leave this at the grids layer. Then we also import our columns. So we'll click here to import our columns, and we created them on our columns layer. So this is one advantage of always working with your layers and always creating layers for your different structural elements. So we'll click on OK. We'll run a quick model check to see if we have any clashing columns, clashing beams, clashing grids, and we do not have any error on this model. So we'll close this, and we use our DXF color so we can as well see whatever we proposed earlier. So we increase the intensity to the maximum, and we can close this. Okay, so now we have our ground floor columns, and we have the lines that indicate the position of our proposed beams. So this makes our jobs a lot easier. Okay, so we get to see what we've exported from AutoCAD into Prota structure, and as you can see, we have our columns that are from the ground floor. So let's come back to the plan view. Then we'll start by creating our beams on these proposed beam locations. To make this easily understood, we get to change our grid lane here. Let it match with the grid lane we have on our AutoCAD. This will just take a minute. Let it match with our grids from our AutoCAD. So when we are comparing the AutoCAD and we are comparing the Prota structure, our grid 1 here will also be our grid 1 on the AutoCAD. So this was, just click on any of this, right click, come to properties, and you can change the label. Okay, so let's see if we have any grid 1. We already have a grid 1, so let's rename this first. Let's take this to grid 19. We'll update and close. And the last one we should be modifying is Y9. So we'll change this from Y9 to H asterisk. We update this, and we can close this. Okay, so there won't be any confusion when you are trying to make modifications to this very structure. So we'll start off our beams by creating them on the perimeters. Okay, so we'll start with our perimeter beams, then we'll come to our internal beams before we can start treating the cantilevers. Okay, so we'll come to here, we have beam here, or come to concrete member and click on concrete beam. So our B here is the width of our beam, which is okay, this has been modified to 230, so we'll take this to 230. And due to the fact that this is a two-story, we'll start the ground floor beams. We'll start these ones at that's the first floor beams. We'll start it at 500. Then the second floor beams we'll take that one to be 450 millimeter. While the roof beams, we'll take those as 300 millimeter. And keep in mind that all of these are tentative sizes. They are subject to change with respect to analysis and design. So we'll leave this at 500 thickness of beam. Then we can draw from here to here. Okay, so you observe that these beams will be breaking along the point of the columns. Okay, so just draw a straight beam to this end, and as you can observe, they are all breaking at what? The column point. So we have the different beams at the intervals of our columns. Okay, so let's take a look at what we've done so far. And this is what we've been able to create to receive the first floor. So let's come here and come back to our plan view. We'll click on this, right click, come to properties. Then we'll run directly from here to this part, run directly from here to this part, run directly from here to this part. Okay, and we've been able to successfully create our perimeter beams. So as you can see, we are putting these beams at ease. We are not making further calculations because we already have our proposed beam locations denoted by these lines. Okay, so let's click on this properties and we'll run a straight beam from here to here. Okay, I think there is an error with our column sizes. Against 230 by 230, we are having a column size of 230 by 220. Okay, so let's rectify this issue. We'll come to column, come here, we'll right click, come to properties, and we'll come here to column wise edit. So these are some of the issues that you get to encounter due to maybe little shift in grid lines. So we take this to 230 and okay, then this other part as well, we'll take all of this to 230 millimeter. So this is okay, and we close. So now we have all our columns as 230 by 230 size of columns. Okay, so we'll start to create these other internal beams. We'll click here, right click, come to properties. We'll draw this from here to this part. We'll also draw this from here to this part. We'll draw this from here to here. And this is the last vertical beams that we have. Okay, so let's take a look at what we've done. We'll right click, come to 3D view, and this is what we're able to do. So these are the beams that are resting on the walls of the ground floor. So now we have to create our cantilevers that will in turn receive those proposed new columns. Okay, so we'll click on beam, right click, take these properties, and we'll say from this part we'll have a beam that will cantilever from here to here. Then we'll also have another beam, or let's put this side by side with the AutoCAD file. Okay, so on grid line B asterisk, which is this, we've already created our beam. We'll click, come to properties, then another beam runs on grid line C to support the newly introduced column. So we'll click from here to here.
on grid line D as well, which is here. We'll click from here to this part. We'll also do the same for here to here. And we have this last one on this grid as this. All right. So the next is we'll come here. Then we'll create this beam here, which we actually cantilever out and cantilever here in order to receive these two new columns. So we'll come back to the ground floor and we'll draw from here to here and here to here. The next is this and this. So we'll come here to here and we'll come here to here. The next is this. We'll come here to here and we'll draw from this to this grid line, which is this. Then we'll draw from the staircase area as well. We'll just connect from our AutoCAD plan. Okay. Then we'll distribute to here from the column. We'll also distribute to here. And we should be having the last one at this edge. Okay. So let's come and close this up. Maximize this. And let's take a look at what we've been able to model. Okay. So this is of what we've been able to model, and this is what we accept our first floor slab. We'll come back to our plan view, and like we said earlier, we can choose to cover this part up. We can choose to cover this part up. Due to the fact that this is actually a short span, it's really not necessary. But just so they do not see the edges of this beam, we can choose to cover this entire area with a beam. Okay, it's all preferences. It doesn't really, so it's all a matter of preferences. So we can click here, come to properties, we'll draw from here to this part, then we'll break it along this point. Then we'll also draw from here to here. Yes, we'll break it along this point. Then we'll draw another one from here to this part. Yes, we'll break it along this place. When you are doing this, ensure that the ones coming directly from the columns are the one that has these arrows, because these arrows that you see over here indicate that this very beam is a cantilevered beam. Okay, so ensure this is not the one having your arrows, unless for this part. Okay, ensure these longer beams are not the ones having the arrows. Let these shorter beams be the cantilevered beams due to their length, and these longer beams should be resting on these cantilevered beams. Okay, so ensure this is your cantilevered beam. Also ensure this is your cantilevered beam, and all these other ones as well. Okay, so we'll go ahead and create this. Remember that this is not really necessary. We'll draw directly from this grid up to this grid, and we can break in between. Okay, so let's close this and come to our 3D view, and this is what we've been able to create. Okay, so the next point is what we'll start to insert our slabs. And to insert our slabs on the beams, what we need to do is click here, and we'll assume a slab thickness of 150 millimeter. Let's take this to 150, and we'll assume a concrete cover of 25 millimeters. Then come to the loading tab. Our self weight has been already calculated. This is the value for our dead load. We can choose our partition load as 1.0, then finishes and others as 1.2, which will lead us to about 2.2 kilonewton per meter square. But we can also come here and select any of these values. Okay, do not forget that you can create these values by yourself. You can create a value for any of these elements by yourself, but due to the fact that we are trying to make these videos as short as possible, we will not be going into that. So we'll select for the room. Then for our impose load, we'll right click here and select general domestic use, because of we are designing for a simple residential structure. So we'll come and place our first slab here. We'll keep this here as well, and let's take a look at what we are trying to achieve. Okay, so as you can see, we already have what our slab position. Okay, so let's come back to the plan view. We'll click on this, right click, come to properties, click here, here as well, another slab here. So we can now slab the cantilevered part. So we'll slab here. This part is too small, so I think we should get an error message for this. Okay, so we'll slab this part as well, slab this part, we'll slab this part, slab this and this, we'll slab this. We don't need to slab this because this is the staircase area. We'll slab this and we'll also slab this. Okay, so we can close up and let's take a look at what we've been able to model. Okay, so successfully we've been able to create what we got on this very layout, which is this is a panel, this is another panel, this is another panel, this is another panel, this is the cantilevered part that will receive the slab for this bedroom. So we're able to create this. Okay, now the next step is creating this other floor that will have our column moving from this position to this other position. Okay, so let's move on to the creation of the next story, and to do that we will come to building setout and we'll click on insert stories. So this is a ground floor plus 2 suspended floor, and that leads us to 3 numbers of stories. So we'll come here, edit and type 3. Okay, so our 3 floors has been created. We'll come back to our story 1 and we'll auto populate this to the next story. So we get to auto populate this to the next floor, and we'll come to building setout, then we'll come to generate story. So we'll generate what we have on our story 1 and let it come to our story 2. Then we'll ensure that we'll take out all these slabs, because due to that increment, what we have on the first floor is not the same as what we have on the ground floor. So we'll take out everything related to slab, but we'll still work with our columns and our beams and walls. So we'll click OK and we'll close this. So as you can see, this is the first floor slab, and we have to make modifications in order to receive what our second floor slab over here. Okay, so we'll come back to our plan view, then we'll minimize this and we'll put this side by side. So we'll put this side by side. Remember, when we get to this level, we are keeping this very column here. Then we are also keeping this very column on grid line B, which is this. We are also keeping this column on grid line B asterisk, which is this one over here. But for the column on grid line C, we are not actually keeping this column. Okay, we are interchanging this with a newly introduced column. Okay, so what we'll do is we'll delete this cantilevered beam, then we'll click on this column here, we'll right click, come to properties, and we can place this here. All right, so let's come to our 3D and let's see what we've done. Let's come to 3D, and as you can see at this part here, we have this cantilever beam coming out, okay, and it's actually receiving this column that is coming at this first floor. So we can in turn take out this column. Okay, so as you can see, let's take out this beam to see what we are talking about. So we have the cantilevered beam here, and it's actually receiving this column that we proposed earlier. Okay, so let's bring back our beam, then we'll come to our plan view. So we've introduced this, then we can as well take out this beam. We will delete this as well. We'll also delete this. Then we can run a straight beam from this point up to, click on beam. We can run a straight beam from this column, which is this, up to this newly introduced column. Okay, so we'll do same thing here. For clarity's sake, let's delete this beam and we redraw and cantilever to this extended column, this extended beam rather. So now we have our slab panel in this manner, okay, for this very floor. Then we'll move from this part to the next, which is our grid line D. And on the grid line D as well, we are moving this column from this initial position to this newly introduced cantilevered point. So we'll click on this, right click, come to properties, and we'll put a column here. Then we can delete this cantilever, delete this as well, delete this, come here, right click, come to properties, then we can draw from here to here. Okay, so the next is this as well. Come here, come to properties, then we can draw directly from this point to this point. All right, so let's close this up and let's take a look at what we are creating. So this is what we are actually creating to receive. This is what we are creating over here in order to receive our first floor slabs. Okay, in order to receive these slabs that will carry the second floor. So we'll come back to our plan view and we'll keep working with this plan as well. So on our grid line F asterisk, we've already made this modification. Let's see. Okay, we have this column here, and it cantilevers to receive this balcony. Okay, so we are good. For grid line G, we are keeping this column, which is this. Grid line H, we are also keeping this column, which is this. All right, so we also move on to this part. And we said that this part will get to cantilever this beam outside. Okay, so this is okay. We are not touching this. But these columns will be transferred to the left and also be transferred downward. Okay, so the cantilevered beam that we've made from the ground floor level will be able to carry these columns. So let's right click, come to properties, we'll put this here, we also put this here. Then we can take out this other column and these corresponding beams. So we'll come here and delete this. We'll also delete this. We'll delete this as well. Delete this. Delete this. We'll delete all of this. So we can get to redraw our beams. So we'll draw this here, cantilever this, let this rest on this. Then we also said at this point, we'll get to cantilever this and let this rest on this shorter beam. Okay? So this is good to go, but it is better we redraw our beams, come to properties, and we'll draw this from this point up to this point. So as you can see, we have another panel here. Okay, so moving on, we said that this part, we will treat this as what? A panel. Then we'll treat this sitting room area as another panel, while we'll treat this at another panel, and we'll treat this as what? Another panel. Okay, so we'll come here to grid line B asterisk and we'll reintroduce a new column here. So we'll get to delete this beam, come to column, properties, and let's introduce this new column here. Then we can delete this, also get to delete this column. Then we'll run this beam from here to here, and we can run this beam from here to what? This part. Okay, so let's also make further modification. We need to reintroduce the beam that we created here, which is, this should be, if this is one asterisk, this should be one double asterisk. Okay, and this is at a distance of 825 millimeter. Okay, so we'll come to our grid line 3. Then we'll offset axis, press your F2, and we are going up, so we'll type 825. All right, so from this point over here, we can get to run a beam directly from the body of this to the body of this over here. Come to properties, come to column, introduce this here, click, right click, come to properties, then we can draw from here to here and from this part to this part. So this will support and it will cantilever it to this beam, and this will also cantilever this to this beam. Then we made further modifications that this column in red will be moving from this initial position up to this new blue column. Okay, so we'll get to delete this and also delete this. We'll delete this as well. We can also get to delete these two beams. So we'll drop this column here, click on here, come to properties, we'll draw from here to this part, and we'll draw from here to this part. So we can leave this as it is, or we can also choose to divide this to two different panels. Okay, so we've made this modification, and the next is this part. Okay, this is actually okay. This staircase area, we have this column here, which is this, cantilevers to join this column, so which is also this, cantilevers to join this. Okay, so we also have to make the same modification on this other right hand side. So that will require us taking out this beam. We'll delete this, and we'll also get to create a column at this position. We'll click on column, right click, click here, right click, come to properties, we introduce this. We'll click here, right click, come to properties, we'll click from here to here and drop this here, and our new beam will run from this part to this part. Then we'll also get to reintroduce this new column here, so we can run our beam across here to here and also to this part. We'll take this out, right click, properties, reintroduce this here, take out this beam, take out this beam as well, can take this out, and we can redraw. Okay, so let's draw this here, then we can cantilever from here to this short part, and let this also rest on this what short part. Okay, so let's close this. Then we have our flush here, which is okay, and the same modification we made to this part is what we'll be making to this other right hand side. All right, so if you find this video helpful at any point, do not forget to like it, subscribe, turn on the notification bell, so when we post other complete videos on raft foundation, pie, slab raft, beam raft, and cases like our pie draft foundation, because we'll be having different series on each of these foundation types. You also get notified at instance. So we'll select this and we'll delete this beam, or let's create our columns first. To create a boundary, we'll create here, we'll also get to create here, then we can delete this, select this and we'll delete this. We'll also get to delete this column, delete this one, delete this, delete this and this, and let's draw our beams afresh. So we'll take from this cantilever to this part, we can cantilever this one, then from this part to here, and we'll also drop this on this cantilever. All right, so now we are done with what this arrangement, we are done with this other floor structural arrangement. So we need to ensure it matches with this. Okay, just do a thorough check and ensure it matches with this, and we start to insert our slabs. So let's come to slab and we'll use the same load properties. Then we can now drop them here, this part, this, and this. Okay, so I think we covered this staircase area, so we'll delete this and let's take a look. So we have our what second floor slabs. Okay, so when they are actually sitting here, when they are actually sitting at this level, that when they're actually sitting at the sitting room here, they will not get to see a dropping beam. Okay, we've been able to manage this very situation. So the next is to create the last set of columns and beams which will carry our roof. So we'll come back to our plan view and we'll come to story 2. Then we'll come over here to our building setout and we'll click on generate story. Okay, so we'll be generating this story from story 2. This is our source and our target story is our story 3, and we'll get to take out each of these slab related properties because we do not have any slab on what our roof beams. Then we'll click OK. Yes. Then we can close this up. And let's take a look at what we've been able to do. Okay. So this is okay, and we've been able to complete the model. Now let's go ahead to reduce the member sizes of each of this level. So we said this will be 500 thick beam, this will be 450, this level will be 450, and the final level here will be 300 beams. So come to level 2, click on beam, right click on this summary table. This is the width, while this is the thickness. So just click here, then click on this part and take this to 450 millimeter. So all these thicknesses will change. All right. Then come to our story 3. We'll click on beam as well. We'll click on beam as well. We'll right click, come to summary table. We'll click here, column wise edit, and we'll take all these thicknesses to 300 millimeter. And we can close this.
So now we are done with our modeling. And moving on to the next phase, we need to insert our wall loads on these beams, because these beams will be exposed to wall loads. So we need to insert those wall loads on them. So what we'll do is we come back to the plan view, and let's start from our story 1. Then we select any of these beams, right click, come to edit beam wall load. So as you can see, we have our dead load here as 0.0 kilonewton per meter, and our wall height, we assume a height of 3 meters per floor, while our wall thickness, we are taking a thickness of 0. That's a 230 millimeter, which takes us to 0.23 meter. And our wall unit weight, we'll be making use of this material, and we assume we take the wall unit weight as 2.87 kilonewton per meter square. Okay, so you can click OK. Then let's come to our 3D, and as you can see, our wall load has been added to this beam. So that's for this beam to take account of the wall that will be constructed on it. All right. So we can copy this beam wall load and apply to every other beams. So we'll come back to our plan view. Then we'll click on this. We'll right click, come to copy beam wall load. Then we'll come to click on the first beam here. Then come down, hold your shift button and click on the last beam. So all these beams will be highlighted. You can as well choose to hold your control to remove some other beams that will not be carrying your wall load if you wish to. Okay, so we can right click and come to paste copied beam wall load. So we'll paste this. Then let's come to the 3D. Okay, and you can see our walls has been taken account of. Then we'll make the same process for this second floor. Let's come to plan view. We'll click on story 2. We'll come to these beams. We'll click here. We'll come down, hold your shift, select all the beams will be highlighted, right click and paste copied beam wall loads. And let's see. All right, so now we have our wall loads imposed on the beams. So at this junction, we've made modification to the thickness on each level. We've also inserted our wall load. So we can see we are done with our modeling, and let's run a quick building model check. Let's see if we have any interfering members, or possibly one of our beams is not on one of these grids. So there could be such issues during modeling. So we'll come to building analysis. We'll come to building analysis. Then we'll come to this analysis tab. Then we can run a quick building model check. Let's see if we have any errors on our model. And as suspected, we have two errors on this model. So let's look at the error here. And it says our slab 1s14 has a very small area. And we actually identified this during the modeling. So this is slab 14 and slab 22 on the story 1. So if we close this, we'll close and we'll come to story 1. This is our slab 14, which is this small slab here, and this other one I believe should be the slab 22. So this is the error the Prota structure is presenting to us, but this is actually negligible. Okay, so that is not much of a concern. Now let's come back to our story 2, and since we do not have any further issues on this model, we can go ahead to run our analysis and start our design process. And we'll begin with coming to analysis tab, then we'll come to building analysis. Then we start from the pre-analysis phase. Okay, so on this pre-analysis phase, let's come to parameters, and we ensure our desired code has been selected. This is BS8110, which we are designing with the corresponding BS code. Okay, so this is okay. We'll come to the next tab, which is the foundation, and we'll change our soil bearing capacity here. We'll change this from 200 to, let's design with a soil bearing capacity of 125 kilonewton per meter square. So the next is our lateral loading. So our BS code specify we apply 1.5% of our total dead load as our lateral load. Okay, so irrespective of the numbers of stories, irrespective of the story height, we need to always apply at least 1.5%. So if we divide this 1.5 by 100, it will give us 0.015. So we apply 1.5% of our total dead load as our notional horizontal load. So ensure this is ticked, this dead load is ticked, and this is 0.015. So this is okay. Then we'll come to lateral drift. For your columns is braced on direction 1 and is also braced on what? Direction 2. So this is okay. We come to the title, and let's give this a different title. Let's call this complete design of G plus 2 with pad foundation. Okay, so this is made by and also checked by. Okay, so this is okay. Then we are done with this. So the next phase is our load and load combinations. Okay, so we'll come to load generator, and we do not have any predefined load here. So to automatically auto-populate your loads and your load combination as regards to the code of design you selected, just click on load generator and it will define your loads for you. So here we have the maximum G factor, which is the dead load, and we also have the maximum imposed load partial factor of safety, which is our 1.4 GK and our 1.6 QK. We can further make modification to this partial factor of safety if we want to, but let's leave it as the standard. Then we can choose to also define further load template, but let's also leave this as the default. Then we come to our notional horizontal load. So the notional horizontal load which we just defined, which was applying 1.5% of our dead load, we ensure this part is ticked. Then we can click OK, and the next is we click, because our load cases and load combinations has already been defined. All right, so we can click OK. We do not have to worry about our wind and story loads because the BS code specifies that you apply your wind load when you get to 10 meters above a flat terrain, and this is a ground plus 2, so we should be having at about 9 meters in height, so it's not up to 10 meters, so we can choose to ignore this. The horizontal load we'll be having on this structure is only the lateral horizontal loads. And let's come to edit our materials. Then we can select the preferred diameter of reinforcement, our concrete grade, and also our reinforcement grade. So to design our concrete columns, we'll design this with a concrete grade of 25/30. Let's use grade 25/30. And let's apply this 25/30 to every other structural members on this model. So we'll come back here, then we'll click on apply to every other members, then we'll click OK. Then all this will change to grade 25/30. Our grade of steel for design, we'll click here and we'll select grade 460. Ensure you can get this grade ensure the grade you are selecting is actually available around your environment. Okay, so we'll select grade 460, we'll click OK. Then we'll select the reinforcement diameter. For the concrete columns, we'll come here and we'll select, let's unselect all. We need Y16 and we need Y20 at the worst case scenario for our columns. So we'll select these two. We'll click OK. We do not have shear walls here, so we can skip this. We have beams, so let's come here to change this to Y16 and change this to Y20. Okay. Then the next is we have slabs. So we need just diameter 12 for our slabs. And the next is what? Our lengths. Okay. So let's select Y10. Let's select Y10 for our lengths. And we should be done with our default materials. The next is setting our foundation materials. Let's come here. We'll select this and we'll leave it at 25/30, same as for the steel grade. And for the foundation level, let's unselect all of this. Then we can select Y12 or Y12 and what? Y16. Okay. The next is our links. We'll unselect and we'll leave our links as Y10. Okay, so we can go ahead and save this, and we are done with our pre-analysis phase. So the next is going to run our analysis. For the model options, leave this at the default. Then we'll come to the analysis tab. So as you can see, no previous analysis has been done on this very structure, so we'll just get to run the first analysis. And this very point in time, we did not intend to design for our columns or our beams. If we take this, it will help us to also design for our columns and design for our beams. But we want to do this separately. Let's just run our analysis, then we generate the moments, the reactions, and every other factors that will be used for the design. So we'll untick these two. Ensure your building analysis is ticked, and we'll click on start. Then click OK. Then our analysis has been completed. All right. So we can go ahead and close this, or let's come to the post analysis. Okay, let's come to the post analysis and check our deflection. We click on model and analysis result display. So this is our structure, and to see the displacement of our structure, you just click on here, ensure here is clicked, and click on the animation. Okay, so this is how our structure behaves, and let's click on each of these loads. Let's check how our structure behaves under the notional loads, which is actually acting by the side of our structure. So if we click on our notional load on the x direction, I will click on these animations. You can see the applied 1.5% is trying to push this load to the side. So the software will take account of this and provide suitable reinforcement to resist this effect. Okay, and also check on the y-axis, and this is the behavior under our notional loads coming from the y-axis. So you can also check for the live load, the imposed load, and every other load on this structure. So let's close this and we'll begin our design proper. Okay, so we can close and let's start with our slabs. So we'll start with the slabs on our story 1, and to design for our slabs we need to run a slab strips across all the spans of slab on this very floor, and we can find our slab strip here, or we can come to concrete member and there is an option for slab strip. Okay, so let's click this. Then we, under this general, ensure you're on the general tab. Under this general tab we leave this, we'll start with the direction x, which is this direction. You start from the x direction, then we'll leave this at analytical strip. Okay, ensure this is on analytical strip. Then we observe the boundary conditions of our slabs. For this first strip of slab, we have it governed by our beams, and we also have the end governed by our beams. So this is the indication for beams, which is indicated by bulb, okay, which is our bending of bars. So we'll click here as the start, and we'll also click here as the finish. Ensure you take note of these start and end boundary conditions. So we'll click here and here, then we'll come here, hold our control, and you hold your control to create a straight line, and we'll click here. So automatically it will design our slabs and provide the suitable reinforcement on that direction. Okay, so now we have, on this direction we have y12 at 250. This is our top bar, which is returning from this beam, and we have here our b1. This is the bottom bar. We also have another top bar here, then we have another bottom bar, and the top bar, which is returning from this beam. Okay, so that's it for this panel. We'll come to the next. You click, hold your control, and click here. We'll do same for this part as well here, and we also click here. Okay, so you can check the reinforcements. These are the provided reinforcements. Then we are done with the x direction, and we'll come to the y direction. Okay, also for this first span of slab we have it governed by a beam, and at the end we also have what, a beam. So we'll click here and here, and we'll start from here. We can hold our control, We'll click here. Then this as well, beam to beam, and another one, beam to beam. So let's make this a little faster. We'll draw here to here. Then from here we can have this. From here we can have this as well. And also from here we can also have this. Okay. So now we are done with the slab design for our first story. We'll move on to the next slab. Then we'll click on story 2. And we'll apply same principles here. We'll launch our slab strip. We'll observe our boundary conditions. Then we'll start from the x-axis. Ensure we are designing with analytical strip. Then draw from here to here. We'll also draw from here to here. You have to ensure all the slabs on this model is touched. Okay, so we can draw from this part to this part. We'll come back and we'll apply same principle here, and we'll draw from here to this, and also draw from here to this part. Okay, we'll go to the y-axis and we'll draw from beam to beam, which is here to here. And the next is, let's start with this. Can draw to this place. So we've already designed this big slab. Okay, then we can draw from here to this part, and we have one slab left on the y-axis. So the boundary condition of this is it will start from a slab and it will end also at a beam. So we'll come to the start here and we'll click on slab. So we'll draw from here and we'll put this here. Okay, we also take same principle here. We'll return back to beams to beams. Then we can draw this. We can draw this across this span, and we can draw this across this span. So you can check the reinforcement as well. We all have Y12 or T12 at 250 millimeter spacing. So now we are done with our slab. Let's generate our slab results and get to see if we have any of these members failing in deflection. Okay, so we'll come to concrete design and we'll click on slab analysis and design. We'll leave this at default, which is 1.4 and 1.6 QK. Then we'll design for all stories. Then we'll click on delete and reselect all bars, and we'll click on design. So you give it some time, and here we have what our design report. We can save this as a PDF, and let's get to look at a few of the slabs. So we have to do our deflection check. Okay, so let's check here. For this first slab, deflection 32.14 is less than 52. So this is actually sufficient. Okay, to check if you have any insufficient sections where you probably get to increase the thickness, or you have any failing sections, you can search for insufficient. So we do not have any insufficient on this slab design, so we do not have any of these members highlighted. But if you search for sufficient, as you can see, we all have them highlighted. Okay, so let's close this. And to get more about slab analysis and design, we've done previous videos on this where we only spoke about slab analysis and design. You can go through those previous videos and get used to the process. So we'll close this, and we've concluded the
slab design. Now the next is our beam designs. And to design our beams, we'll come to concrete design. I will click on beam reinforcement design. Then we'll click on story beams. So by default, every of these beams on this model should be failing because we've not done any previous analysis, any previous design. So what we'll do to design these beams is we'll click on beam design batch mode, and since we are designing the beams on all stories, select all stories unless except you want to design for a specific story, and we'll click on reselect all bars. So this will perform a thorough design, a fresh design. So we'll click on calculate, and our beam design has been completed. So we can go ahead and close this. And there are a few things we should be checking on our beam designs. The first is our utilization ratio, which is here, which is the U ratio. So the first check you have to make is your utilization ratio, which is a calculation of your strength, the strength of your provided section against the magnitude of load or the moment that is acting on that very section. Okay, to get more about this, we have a specific video on beam analysis and design. You can go through that video, and there is a step-by-step process on how you can calculate this. But it is always advisable you keep your utilization ratio between the range of 75 or maximum between 75 to 85% due to uncertainties. And there are ways you can tweak your beam design in order to match your required utilization ratio. So let's check what we have provided for the first beam here. If we click on this, and this is the top bar, this is the top bar of our section, this is the bottom bar of our section, this is the supporting top bar, which is provided at the support region. Okay, so this is our span region, this is our support region. So we have 2y16 provided at the top, okay, and we also have 2y16 provided at the bottom for this very specific beam. So it runs up to this last part. We all have 2y16 top and 2y16 bottom. So let's come to detailed drawing and let's see what this beam looks like. So as you can see, we have 2y16 at the top and we have 2y16 at the bottom. Okay, so this is the full length of our links. These are the different sections of the beams. This is a 230 by 500 and this is a cross section. Okay, so if you intend to increase this reinforcement, you can click here to increase the numbers and you can click here to reduce the size. Okay, so we'll stay with 2y16. Then what we require you increasing these numbers is if you have your extra area of steel provided here below 100. Okay, so let's come to this section and let's reduce this. You see, if you have no reinforcement provided here, we will have this moment here as -105. So we need to provide reinforcement in order to cancel this moment. So if you provide one number of y16, we should have something of 95. Okay, we are having 95 here. So this 95 is a measure of the extra area of steel provided above what is required to satisfy this moment. Then if we take this to 2, you will see that the value here has increased. Okay, so this part is for the top bar and this part is for the bottom bar. Okay, so let's take this back to 2y16 And like I've said, there are videos on specifically on beam analysis and design. You can go through those videos where we took time to explain these processes. So let's close this, and you can check the reinforcement for each of these beams. Okay, you can check the reinforcement for each of your beams and tweak it to suit your desired utilization ratio. So let's work with one of these that has a high utilization ratio. Let's start with this having 99. You can click here, and as you see, we have 2y16 provided at the top and 2y16 also provided at the bottom. So in order to increase the capacity of this beam, we can take this to 3y16. Let's take all this to 3y16, and let's see what we have. Then we'll take this as well to 3y16, and as you can see, this has been reduced from 99% to about 82%. So this is not very cost effective. It is not very cost effective to just increase those members. Another way you can also deal with these issues is if you're having a high utilization ratio, you can as well increase the thickness of your section. Okay, so you can come to beams, and the thickness here, which is 500, you can choose to increase this to 600. You can go back to our previous videos, and since this is okay, let's cancel, and we are done with what our beam design. So the next step is to carry out our column design, and let's come to concrete members. We'll click on column section design. We'll also click on column design batch mode. We reselect and we design. So our design has been completed. We can close this, and we have all our members passing. Okay, we have our members passing, and this is the ratio of the usage of the capacity of the provided reinforcement and concrete section. So you can also tweak this, and let's open up the first beam. Okay, the first column. So we have a section of 230 by 230, and this is the provided reinforcement, which is 4y16. We have the 4y16 here. So if this column was failing, what we can do is provide extra numbers of reinforcement here. So we'll come to internal, this internal on direction 1, which is the x-axis, and we can choose to put one quantity. Okay, so if we put one quantity, it will bring out reinforcement at the top and the bottom. So we can also put one quantity at the direction 2, but this is not required because 4y16 is actually suitable for our design. So this is how you can tweak this. So we provided 2y12 here on the x direction. If you want to change this to y16, come here and change this to y16. If you need to change this as well, but since we have this 4y16 sufficient, we'll cancel. Okay, so these are the provided reinforcements, and this is the links. This is the spacing of the links. So to create our design report or our calculation sheet for our columns, what we can do is come to design report here. So let's unselect all of this, and let's use this other type of report. Okay, so this is our column design report. Okay, you can save this. And let's close this. All right. So now we are done with our column design, and the next stage is moving on to our foundation designs. So to design for your foundation, what you need to do is come to story 0, and as you can see over here, we have just the columns that are coming from the ground floor to the foundation level. And first, let's come here to check our design status. Come here and come to this visual interrogation. Then scroll down and come to design status. Then we'll click OK. So we check the design status of our members. As you can see, this is green. This is the map to read each of these info. If we have any red member here, we will have, that means the member has failed. Okay. If we have any of these yellow members here, so it means the analysis has expired. But this design is okay, so each of these members has passed. That's why we have everything in green. So let's take this out. Then we'll come to none. Okay. Then we'll come back to our plan view. So the next phase is designing for our part bases. And to design for our part base is very simple. All you need to do is click on the column you intend to start with. Then you right click, come to insert pad base. Okay, so we'll click insert pad base, and we have some parameters to fill here. This is the thickness of your pad base. We can start with a smaller thickness. Let's try 350 mm. And if we've designed about 5 pad bases and maybe at the 6th pad base 350 mm was not suitable, or it failed in one of the checks, it could be punching, it could be shear, it is advisable you go back to your previously designed section and increase that thickness from the 300 to from the previous section to the section that was okay for your last design. Okay, so let's come here, take this to 350, and our soil bearing capacity is already here, and let's design the foundation level with Y16. So we'll click on calculate, and a section has been provided for us. So we have a pad base of 1.3 meter by 1.3 meter. So we can make this a square footing. If we tick this, it will stay as the square footing. Okay, so let's click OK, and we'll click what? OK. So this is the pad base. Then we'll come to the second column. Now let's design this as a rectangular footing. This should be a square, while this should be rectangular. So we'll click here, we'll come here, right click, insert pad base, calculate. A section of 1.8 by 1.8 has been provided. So we can choose to make this a rectangular footing. So if we increase one of this side, if we increase the x-axis, you see that this side will also reduce. Okay, so let's take this at 2 meter by 1.5 meter. So you ensure you do your checks. This is for the punching checks. You do these checks, check if it's okay. Do these checks as well. If any of this is failing, either in punching or shear, it will be indicated here. You will see failed here. Okay, so it means the 350 mm thick of assumed pad base is actually sufficient. So we'll click OK, and we'll click what? OK. And now we have what? Our rectangular footing. Let's quickly design this as a square footing, and OK. So for this case, we can combine these two footings. Okay, so for this case, we can combine these two as one footing, so they can share the same base. So to do that, we'll select this, we hold our control, click this, then we'll right click and come to combine selected columns and words. Okay, so click this and we'll click on yes. Now we'll come here, select
right click, come to insert pad base. We start with same parameters. We'll come to calculate and we'll make this a square footing. So if we decide to design as a rectangular footing, you can see this is actually failing in the x direction. So let's make this what? A square footing. So it has provided a section of about 2.1 millimeter, or let's say 2.2 by 2.2. But you also have to observe the distance from this column edge to the edge of your pad base. Ensure this is around about, let's say, 200 millimeter minimum. Okay, so we'll click OK and we'll click what? OK. So always ensure that you have enough allowance from the edge of your column to the edge of your pad base. So let's increase this pad base. We'll click here, right click, come to properties. We can recalculate and let's take this size to 2200 by 2200. So we'll click OK and we'll click OK. So we have enough allowance at the edge of our column. Can continue with the same process. Insert pad base, calculate, OK, and what? OK. So this is how you can design your pad bases, and we'll make this a little faster. And we'll insert the last pad base. OK, and OK. So we've completed the design of our pad bases, and let's come to our 3D view. And as you can see here, we have what? Our complete design. So let's check the design status. So we can come here, and this is the design status of our complete model. So the next is exporting these details so we can see the provided reinforcements in the pad bases, in the beams, in the columns, in the slabs. We need to export this to Prota details. So to export this to Prota details, come to concrete design and click on load Prota details. Let's save this. Then we'll click on auto generate drawing. So this is our Prota details. So click on auto generate drawing and ensure all these stories are ticked. Ensure the column is ticked as well, beam, pad, footing. So we'll click on draw. Then just click on anywhere on your screen. And we have the provided details. So this is the plan of our pad and pad bases. Okay, and if we come down to this part, if we come down here, you will see the detailing of our pad bases. So for this, we have 6x16 running at 250 mm. We also have 6x16 running at 250 mm, both on the x and what? The y axis. This is the section of our pad base. This is the thickness. This is the 350 mm thickness. This is the concrete. This is the blinding. This is the reinforcement. This is the concrete cover. And same as this, we have 8x16 running at 225. While on this other direction, we have 9y16 or 9016 running at 250 mm spacing. Okay, so these are the details needed to construct your pad bases, and this is the story 1. These are our story 1 beams, 1b1, 1b2, and the lights. Then if we come back here, we can see our beam detailing. Okay, you can see the beam detailing, the reinforcement required for our beam, which is 2h16 here, both top and bottom. And we also have a section for our beams. This is our slab detailing, our Y12, H12 running at 250 millimeter. This is the bottom bar here. This is the bottom bar here. This is on the shorter span, which is our B1. This is on the longer span, which is our B2. This is the returning top bar. This is the top bar countering for the hugging moment at this support span. This is also another support bar for another top bar for our hugging moment. Okay, so this is how you can complete a design on Prota structure. If you found this video helpful at any point, do not forget to like it, subscribe, and turn on the notification bell so you get notified anytime we post new videos on our channel. And these other ones over here are our column sections. So with this, we can round up this complete tutorial on how to design a two-story residential structure with a pad foundation.